This video is going to introduce us to heat transfer, and we're going to talk a little bit about why some metals heat up faster than others, and kind of try to explain why like your coffee gets cold when you leave it on the counter, or why your iced coffee gets hot when you leave it on the counter. So I want you to take a second and think, if you were to touch a metal spoon and then touch a plastic spoon, which one do you think would feel the coldest? The metal one or the plastic one? Now I want you to think, which one would melt ice faster? So if I was to put a little piece of ice, and I can maybe just draw it, like put a little piece of ice right here, which one do you think would melt the ice, or which spoon would the ice start melting faster? If we were in class, we would actually try this on our own. And what we would see is that the ice in the metal spoon would actually melt first. And then the ice in the plastic spoon would basically not melt at all, or hardly at all, while we were, in the couple of minutes that you would be holding these spoons. So let's talk about why that is. So when we talk about heat transfer, when you were holding the metal spoon, or when you hold something metal, sometimes it feels cold. And the reason that it feels cold is because that energy, or the heat energy, is actually being pulled away from you. So the energy that's, the warmth, the energy from your fingertips is actually being transferred into the metal spoon. Whereas the plastic spoon wasn't really pulling any energy from you. So no heat was being transferred from you to the plastic spoon, which is why it didn't feel cold. And then we know something feels hot, right, when the heat energy is moving towards us. So like if we stand in front of a fire, right, we know that fire is hot because we can feel the heat, right? We can feel the heat of the fire coming towards us. So it's important that you know this definition. Okay, so temperature is just a measure of the average kinetic energy of a substance. The important thing is the average, right? Sometimes we might, not every particle is going to move the same speed. Overall, they should move somewhat of the same speed, but it's just like if I told all of you to run fast, you're not all going to run at the same speed, right? Overall, the average is going to be faster than if I told you to walk. But not every particle is going to be moving at the exact same speed. Okay, but the higher the energy, the higher the temperature. We remember that from the food coloring experiment with the beaker of water. Heat is a little bit different. Heat is the actual energy that's being transferred. Okay, so heat is, I meant to write energy there. Heat is energy. So when we say energy is being transferred, or this, I feel the heat, you feel the heat from the fire because you're feeling the energy move from the fire, right? It's being released towards you. It's important to know that we also measure energy, heat or energy in joules. That's the unit, just like we measure mass in grams or length in centimeters. We measure heat energy in joules. So we know, right, that if we set a hot cup of coffee on the counter, that it's going to cool off, right? Well, the reason is because that the heat from that coffee cup, right? So here's my little coffee mug here, right? And it's on I'll put it on a little plate. The heat from that coffee, right, is going to escape from my coffee mug, right, over time. Well, the reason why is because it is cooler, right, on the outside of the mug, and it's hotter on the inside of the mug. So energy is always going to move from higher levels of energy to lower levels of energy, right? It's always going to move from hot to cold. And that's what the picture is trying to show you. The picture is trying to show how we're starting out with high temperatures over here. So we can see our particles are moving very fast. That's what these arrows are trying to show you. And then here we have our low temperatures, right? So our particles are moving a little bit slower. Our arrows aren't quite as long. But over time, eventually, all that energy is going to transfer. It's kind of like sharing the energy. So we reach something that we call a thermal equilibrium. Basically, that just means that our temperature on both sides are equal. So we have equal temps, equal temperatures, right? Or equal, I'll have to make it fit here, equal energy. So the temperature is the same, right? Your coffee is not going to get colder than the room that it's sitting in, but it's going to be the same temperature as the room. So what does this have to do with the spoons, right, that we talked about at the beginning? Well, something about that metal spoon made it easier for the energy to move from your hand to the ice. What that's called is specific heat. So this is a fancy word, science word, that really just talks about it's the energy required to raise the temperature of something. So basically it's like, how much do I have to heat it up in order for me to detect for the temperature to actually increase, right? So a good example of this is something like a pan. So if I have a pan like that's sitting on my stove, right? So I'm putting it on the stove. It's going to start heating up, right? And then I have some water in this pan, okay? What's going to heat up first? Is the pan going to heat up first, or is the water going to heat up first? Well, the pan's going to get hot first, right? But it's going to take some time for the water to start to boil, for the water to get hot. That's what the saying, you don't watch a pot boil or whatever, right? So the pan's going to get really hot. I'm not going to touch the pan, but the water's not going to get hot very fast. Well, the reason why is they have a different specific heat. They're different substances, so they take a different amount of energy in order to heat them up. The pan only needs a little bit of energy in order to heat it up, whereas the water is going to need a lot of energy. The water's going to have to sit on the stove for a while, right? 5 minutes, 10 minutes, before it actually starts to boil, to heat up. So this chart just shows some examples of some different substances and their specific heats. So here's water, right? Water is really high. This high number means that it needs more energy to heat it up. Whereas, an iron pan, aluminum, right? This is gold over here at the beginning. So these materials that we typically cook with, like iron, steel, their specific heat is a lot lower. So here we have a high specific heat. So I'm going to say high specific heat. Okay, that means it needs more energy to, I'm just going to say heat. So the higher the specific heat, the more energy it needs to heat up or raise the temperature, however you want to think about it. So let's think about our metal spoon, right? Our spoon is metal. We know that it melted the ice faster than the plastic spoon. So what do you think about its specific heat? It's going to have a lower specific heat, right? Because the higher specific heat, the more energy we need. The lower the specific heat, the less energy. So it didn't take very much energy from your hand in order to start melting that ice, right? almost as soon as you hold the spoon, the ice is going to start melting because it's pulling all that energy from your hand. You're going to heat that spoon up really quickly just by holding.